Hey guys, welcome back to the P2P Network Coding Session Series. This is episode 31. And today we're going to be working on in one of the notes that I have events. Yeah, we need to sign the events with the social persona identity or social trading bot. Today we are signing only with the user app. And we are verifying at the connection level that the user app is who we think it is. Okay. But there is a need for making sure that we sign also with the identity of the social persona that is sending a message, especially an event or the social trading bot. Because what happens if you have authentication only at the app level? Remember, an app connects to node number one, but then the events start flowing through the network. So other recipients need to certify they're not going to be connected to the guy who sent the event, uh, but they need to certify that the entity sending the event is who we think it is. Okay. Um, so let's go to the code. Um, okay, I got a desktop and I'm going to get things ready here. Okay. So which would be the place to sign this stuff? My guess, desktop app. Okay, desktop app have its interfaces and this guy. That is the peer-to-peer network client. And inside that guy also we have this service that is called social tradis, social graph network service client. Okay. Since the social persona and the social trading bots are entities belonging to the social trading project, and the social graph idea is also belonging to the same guy, so what you're going to do is sign the message here. We are not going to sign queries because a query by definition is a request done to a network node. Um, that doesn't flow through the network. I'm not sure if we're not going to sign queries. Maybe we should, as a way to have everything authenticated. um, in my mind, I don't see it as a requirement right now, but probably it makes sense. It probably makes sense. Okay, let's check this out. So here we have an event. We are parsing the event because the event message might be modified, and also we need to use it to see if it is something that we should take action before sending it to the network, like a post. Okay, then we put it back here and then we send it. So this looks like the right place to sign. I'm going to stop here and debug this. So the network is running. So let me debug this. Okay, let's see this. Okay, so the event message is there. The network service the message header includes the request type and network service. My first question is, okay, we are going to sign this message. What are we going to sign exactly? We cannot sign a static stuff, like static text, because then the signature is always the same. We need to sign something that has changes. Okay, so the event message is a good candidate because it has, in this case, the post hash. It has a timestamp. The only problem is that it has a lot of information, and the signature then duplicates the information at the minimum because it puts everything again as a message of the signature. So probably I will sign the timestamp. Um, I will sign the timestamp inside the event message. It's a minimum amount of information that is changing all the time. So it nobody can take the message and replay it somewhere else. Okay, so that's what I'm going to do. But at the same time, I have to check that the timestamp is present. Okay, so if there is no timestamp, okay, at this point we are going send the message. Okay, so this comment is also useful. I'm going to make a small improvement here. Sorry for diverging, but no, we're not going to do this. Okay. Um, okay, so let's focus on this. So here we still have the event message, and we're going to say if event message dot timestamp. Yeah, we're not going to force the client sending a timestamp. I can generate the timestamp by myself. So if there is no timestamp, we will generate one. Okay. This will be the social entity signature. So if there is no timestamp, we will add one timestamp, and we are going to sign the message. Okay, to sign the message, I will refresh my memory how we did it at the WebSockets interface. That's network. Okay. So the signature is going to need a private key, of course. Um, whatever we are going to sign. In our case, we're going to sign this timestamp. I'm not sure if I have to put a toString or it just works like that. Yeah, maybe I will do a toString. Okay, so we are signing this and we are going to use We have the same problem that in this case we need the social persona that is running this in order to get the private key. Yeah, but this is the default social persona. We need the actual social persona. So we need to do something similar to what we are doing here. The social entity. We need a social entity. So all this code, that by the way is repeated several places. Okay, so this I'm going to extract this. I come back to you in a while. So, yeah. Now the question is, are we going to sign all messages or only events? Okay, my understanding is that only events. So after we set this, since all the messages are to be signed, then we are going to continue here. The social entity must have, okay, so we need the social entity so as to be able to sign this event. Okay, we also need it for post. Okay, so we got a social entity. And once we have it, cannot locate the origin social entity. Okay. Once we have the social entity, if we have to save, we're going to send this to this guy. Because we already have the social entity. Okay, and from here, everything is the same. So the load from post is a totally different circuit. Okay, but this is not our current problem. So now we have the social entity. So the signature will be, we will use the social entity config code name. Okay, then we get the private key of that social entity. Then we have the signature. And the signature is going to go inside the event message. Okay, so what you're saying is that at the event message, we are going to add the signature of the social entity that is producing this event. Okay, this is the real explanation why we are doing this. Okay. Well, good. Okay, so we will need Web3 library. Don't know if we already have it. Okay, so there we go. We got this, the timestamp sign. Where are we going to check for this? My guess is that this will happen at the code that runs at the network, social graph network service. Maybe here. So this is an event receive client interface. What is this? Or maybe the validations are here. We don't have set event that don't have an event ID. Blah 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 blah. There's something else that I'm seeing here. That I don't really like. We have inquiry, we have initialize, finalize, and execute. So the initialize is initializing things and execute is executing. But first, I don't like the word execute because we never use it and we used to use run. Okay. But at the same time, we have that on the event module, we don't have an execute or run or anything. Everything occurs on the initialize, which I don't like. Just for standardization, this should work in the same way. Okay, so first I'm going to finish with the signature, then I'm going to come to fix this. So I'm going to take note. Is 0. Then events should have run function, not only initialize. And the second thing I want to fix is that queries replace execute for run. Okay, I will do that extra job at this same session. Okay, so the place where we're going to check for this is here, because here is where we are doing all these validations. So we're going to check. Okay, also this, I will not consider using social trading bots, only social personas. Okay, so there's another upgrade to be done. Okay, so how do we do with this stuff? We need to validate the signature. How are signatures validated? Okay, the signature, this is how we use a signature. With a signature, we recover a blockchain account. With the blockchain account, we get the user profile by blockchain account. With the user profile by blockchain account, mm, what do we do with the user profile? So what is the problem we need to solve? When an event goes from a client to the network node that is connected to, the client declares a user profile, and the node validates that that is coming from that user profile, and then we have the user profile well known. Good. When the event goes from one node to another node, the problem is, how do we know that the event that you are sending me, you didn't invent it and put it on the name of some other people that is not you? So I need to, because now to the network service, to the node number 2, the client is not connected. So there is not an authentication at the connection level. So then I have two things. I have in the message the social persona ID, and I have a signature. Okay? So what I need to prove or to check is that that ID belongs to the same profile, the same user profile that the signature. Okay? Then I can. And how do I know that it belongs to the same profile? Because from the signature I can get from the signature I can get the user profile, because I get a blockchain account and I have a map with all the blockchain account associated with a user profile. And I also should have a map of user profiles by social entities IDs, that I don't think I have that one. So if these two things lead me to the same profile, then I effectively have validated that that message is belonging to the right entity. Okay? Okay. But then how do I check that the message was not changed? It came from that entity, but somebody changed the content of the message. How do I check that? Then I have to check the hash, and for that I have to sign, like it or not, I have to sign the whole message. And hash the message the same that it's doing here, to be honest. Hash the message and make myself sure that that my hash is equal to the hash provided in the signature. That cannot be changed, because if you change that hash, then from the signature I cannot recover the blockchain account. So that is how things are tied together. So it's not enough to sign the timestamp, but the whole message. So let's solve all the pieces of this puzzle. First, I will write this down here. First, sign the whole event message. Second, create a map of user profile by ID of the social entities. Then C, validate the signature blockchain account gets the same user profile than the ID the social entity at the message. receive. D, validate that the hash of the event message is the same as the hash coming at the signature. Okay, so four things to do, and I thought we were close. Okay, so let's go back to the client side. Okay, it's okay to have the times tab there. So this comes here. This comes here. Timestamp require, so that the okay, so we just added timestamp first, and then we're going to do the signature. And my guess is that we're going to add this signature to this message header. So okay, so what we are going to sign is this, the whole event message that was already stringified. Okay, this is what we are going to sign. So point number one, sign the whole event message. Done. The message is going to be bigger, but you cannot attack it, which is cool. And the good thing is that the signature doesn't really, it's not stored at the social graph. So it doesn't really bother that much. Okay. So that's one thing. The second thing is create a map of user profile by ID of the social entities. That is on the other side. At the bootstrapping process of the social trading, not the network, but the social trading. Does this have a bootstrapping process? Yes. So here we are indeed creating maps, social persona. Oh my God, we already have it. User profiles, by social entity ID. Somehow, when I did this, I could see that this was needed or going to be needed. Okay. At the client interface, queries need to be emitted by a social entity that belongs to the user profile that is connected at the network node. Okay. And this is true because this is the client interface. And at the event interface happens the same stuff. At the client interface, event need to emit it by social entity that belongs to the user profile that is connected at the network. Okay, this is an extra verification, which is true. Okay, that means that it's not here where we have to add our validation. It is in here, peer interface. The peer interface, if you send a query from another network node, it's going to tell you this is not supported, okay? We're going to remove this because it's duplicating what we already have at the other side. So at the client interface, we don't need to check the signature because we are already checking the user profile persona is the same user profile that we already validated at the connection level. So there's no need to check for the signature or the hash or whatever because it was sent by the same through the same connection. It was sent through the same connection by an entity already validated. Is it possible that somebody changed that between the sender and the network node? Well, technically, yes. That means that what we need to validate probably need to be validated at both places to be 100% secure. That means that we will need to run the validations inside an utility function. Okay, but this client interface is social trading. Okay. Okay, so let's return to our list. Create a map of user profile by social entities. We already have that map. Perfect. Okay, now I'm going to create a common place so that we can check the same stuff in both interfaces. Okay. Um, so we're going to call this guy event signature validation.js or validations. All right. Okay. So we will execute this from here and there. Okay, and this is going to be called like this. We'll add this to the project schema, close to this guy. Okay. 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 So what are we going to do here? Okay, it seems that we're going to do a lot of similar stuff to this. Okay, let's copy this and see what holds. So from the client interface, we have the event receive message. But before that, we have the message header. Okay, so we could say that this guy is going to receive both this and the signature, because this is going to have a signature. So the event message, the signature, and to put it more cool, we're going to do like this. This is easier to read. Okay, so we have the signature. So this happened only at the client interface. We check a lot of stuff that is obvious, and okay, and here we will add the validation. We will do um, okay, and we will need okay, we will need this prefix from here to put it. And the name of the function we want to execute is and we're going to send here the event or we can send the event receive and the signature. So if response so if there is a response, then it means that something went wrong and we need to abort. Okay. Okay, and that's it. If there is no response, then it continues and do the same thing that always. Okay, so we will have this event receive that is already parsed and signature that is also already parsed. So first thing, signature is undefined. We will say event signature not provided. In this case, we are not having this, and we return this response. Good. We already have the signature, so no need to do this. Okay, so this is going to be the social app, not social app, social entity blockchain account is what we are going to recover from the signature. Okay. If we cannot recover this, then we are going to say event bad signature. And we are going to return this response. All right. Okay. So we have this guy that we're going to use it through this guy. And this is going to be user profile by blockchain account. Okay. So if we cannot get this, then not link it to user profile. Okay, and in that case we also return this. Good. But still here at this user profile, this is the user profile we get from through the signature. Okay, then we will verify that the signature belongs to the signature message. So in our case, we will verify that the signature belongs to the event message. To do this, we are going to hash the event message and see if we get the same hash of the signature. Okay, so we had here event received, so we're going to do that event message is going to be equal to JSON stringify event receive. So if we hash this guy, we get a hash. Okay, so if this hash that we got is different to signature message hash, then event message hashed does not match signature message hash. Okay, and then we return. The user profile based on blockchain account based on the signature, it's our Wisnet user profile. To validate the social entity ID received, we need to get which is user profile that social entity ID is linked to. So that social entity ID, and here something happens similar to what we were doing here. Social entity event message. Now in our case we have event received. Uh, In fact, what we want to have is user profile by social entity ID. So the user profile by social entity ID is going to be this guy. Okay, so the next thing we are going to do is just to verify if this is not undefined. Social entity ID not linked to user profile, and we return. Okay, and finally we will check that the user profile by we got the signature is the same as the user profile we got from the social entity ID. So if this is different, if the ID of this guy is different to the ID of this guy, then social entity social entity ID user profile not the same as signature file. Okay. Well, that's not much. Which is the thing the network no handle to avoid mining, whatever. We check that the timestamp in the signal is one of the no. So if nothing gets into here, then it will return undefined. meaning that we pass the validations. Okay, so the last thing is to add these 3 lines to the peer interface so that each node can validate that this is so event receive. Event message signature. So this is similar but without the user profile. Okay, so this completes the list. Validate the signature blockchain account, get the same, validate the hash, blah blah blah. Okay, so we wrote all the code. Now it's time for testing. Okay, to recap, we added a new module, the product schema. We modify this to sign the message. And modify save post storage so not to repeat this code. Then at the client interface, we added this small call at the peer interface also. And we created this code to make the validation. So I don't think this should be difficult to test. So at here, social graph service, we'll run a breakpoint through here and then check this part. And at the network side, we will stop the network node and we will go to projects, social trading, client interface. The peer interface, we're not going to check it because it's the same, almost the same, and it's difficult to test. Message receive. What's going on here? Um, this client interface, where is this? NT client interface. Okay, and here we are. NT modules, social trading. Okay, this is trading signal, not social trading. So social trading. Okay, here we are. Not trading signal, but this guy. Okay. So we will stop here. That's it. Okay. So here we go. Oh, wait a second. I don't remember if we had the library Web3 in here. Okay, so we will need Web3 there, otherwise it's not going to work. So we will just put it at the beginning. Okay, so I don't need you. Let's go. Okay, this is running. And this should also be running. Okay, so I will create a post to test all this stuff. Okay, so we got a social entity. We will save the post. Then these already have a timestamp. So we stringify the message. It's not that big, not that small. Then we have the message header. And we will sign it. We will sign the event message. Social entity config. Oops, here there is a problem. Social entity config no, because the social entity is not the node. We need the node config codename. Okay. Social entity node.config.codename. So let's run again this. Okay, so now we might get this sign. Yes. And then the whole message Oh no, I put it on the event message and not at the header. So we gotta do it again. Oh, what happened? Okay, so we change, we are at the other side. Event receive is this. The signature is this. So far, so good. So we come here. Signature is undefined? No. Signature recover. We got a blockchain account. Is it undefined? No. So from here, we have all the user profiles by blockchain account. We get the user profile. Okay. Yeah. So it's me. Good. So is this undefined? No. Why do we need signed message? Probably we don't need this guy. No, we don't need it. So what are we doing here? Even message, even receive, even message. So even message is this. The hash of this is this. And the signature hash is this. They are different? No. This is 2b3 and 2b3. So the message was not changed by a man in the middle. And then finally, so do we have this? Yes. So the social entity ID is this. And the user profile by social entity is this, which is my own profile. Okay. So this is undefined. No. So could we get a user profile? Okay, this is not by blockchain account, but it should be user profile by this. Okay, is it undefined? No. So is this equal to this? Yes. So it doesn't fail. That means that response is not undefined? No. So it continues and records the event, and that produces a response that is okay, and everything works perfectly well. Okay, so the last thing I'm going to check is this post was actually saved. So I'm going to refresh this page. Okay, perfect. We have one more post with default text. Okay, wow. Okay, so we finish. We are going to commit this. So signature by social entity done. Okay. Um, so this was an interesting episode because we essentially signed the message with a social entity private key, which allows the entity to travel through many hops, any number now, of network nodes, and we can still be sure that every node is going to accept the event and that the content of the event text has not been altered because we are checking the hash, and that they both belong to the same user profile. The signature point to a user profile, and the idea of the social entity belongs to the same user profile, and that is enough proof for us to accept that event at any network node and to forward it further. Okay, so that's all for now. um, at the next episode I will continue processing the list. We will see what's there once we are back. Okay, thank you for joining me today, and see you next time.